In this lesson, we'll continue working on our application built with the hexagonal architecture in mind and create the interfaces known as ports defined by the application layer as well as the adapters that will implement them. Ports define the contract for interactions with the external world, while adapters implement these contracts and serve as a bridge between the application layer and the external systems. Before we proceed, let's first install the dependencies that we'll need in this lesson. For demonstration purposes, we're going to use the TypeORM library to implement one of the repositories and the PG library to connect to a PostgreSQL database. Back to our task at hand, let's create a new folder in the application directory called ports. Inside of it, let's create a new file called alarm repository with the following content. This here is our first port, which defines the contract for the alarm repository. It defines two methods, findAll and save. The findAll method will return a list of all alarms, while the save method will save a new alarm to the database and return that saved alarm. It's worth noting that both the class and the methods are abstract, meaning that they don't have an implementation. This implementation will actually be provided by the adapters, which we'll get to in just a moment. Note that instead of using abstract classes, we could use interfaces here, but the reason we chose to use abstract classes is that they serve as injection tokens in NestJS, while interfaces are purely TypeScript constructs and are wiped out during the transpilation process. Essentially, this means that they would not be available at runtime, making classes a much better choice for us to use. Now, onto the adapters. Inside the infrastructure folder, let's create a directory named persistence. This folder will contain the adapters that will let us interact with different data sources. In our case, we'll be using a PostgreSQL database and interacting with it via TypeORM, as well as an in-memory database for demonstration purposes. Note that TypeORM or Postgres are not required by any means. You are welcome to use any ORM or database of your choice to achieve hexagonal architecture in your NestJS applications. So, let's create two new folders, respectively in-memory for the in-memory database adapter and ORM for the TypeORM database adapter. Let's start with the TypeORM adapter. Inside the ORM folder, let's create a new file called alarm entity under the entities directory with the following content. This class will represent our database table and will be used by TypeORM to map the data to and from the database. Next, let's create a new file called alarm repository under the repositories directory with the following content. Here, we're simply delegating the calls to the native TypeORM repository, which is injected into the constructor. However, we can see that some of the lines are highlighted in red. This is because our TypeORM repository returns the entity, our persistence model, while our application layer expects the domain model, which is alarm instead of alarm entity. So we need to convert the entity to the domain model and the opposite. So let's go ahead and do that now. To achieve this, let's create a new mapper file called alarm_mapper_ts under the mappers directory and give it the following content. This alarm mapper class exposes two static methods, toDomain and toPersistence. The toDomain method converts the entity to the domain model, while the toPersistence method converts the domain model to the entity. Nothing too fancy here, but most importantly, we need to ensure that the severe property, which is represented as the value object in our domain model, is converted to a regular string and the other way around when converting from an entity to the domain model. Back to our repository, let's use our new alarm mapper to perform these conversions. Great. Last but not least, we need to create the new ORM persistence module file under the ORM directory with the following content. Using the custom provider syntax here, we're telling NestJS to use the ORM alarm repository class whenever the alarm repository token is requested. We're also exporting the alarm repository token so that it can be used by other modules as well. This is where we bind the port to an adapter. Excellent. Now, let's create the in-memory adapter. There's going to be a lot of repetitive work here, so let's go ahead and copy everything over from the ORM directory to the in-memory directory. But of course, we'll need to make a few changes. Let's start by first opening up the alarm entity file and remove the type ORM annotations, as we won't need any of that in the context of an in-memory adapter. The alarm mapper remains the same, so technically we could move it to the shared directory. But since for more sophisticated adapters it might be different, we'll keep it here instead. Next up, onto the repository. Let's open up the alarm repository file and remove the inject repository dependency. Let's also rename this class to in-memory alarm repository. Inside the body of this class, let's create a new map that will act as our in-memory database. With this new map in place, let's update the find all and save methods. Last but not least, let's rename the ORM persistence module to in-memory persistence module. Also, let's make sure to rename the module to in-memory alarm persistence module and remove the type ORM import. Fantastic. Now we have two adapters that implement the same port. Now onto the fun part. Let's see how we can use them in our application. First, inside of the root of the infrastructure directory, let's create a new file called alarms infrastructure module with the following content. This module is responsible for exporting the correct persistence module based on the driver that we pass in. Both the in-memory alarm persistence module and ORM alarm persistence module export the alarm repository token. We can easily swap one for the other. With that in place, let's navigate to the alarms module and declare a new static method called withInfrastructure. Here, we're using the module's composition pattern to allow the consumers of our module to pass in the infrastructure module that they want to use. This is a very powerful pattern that allows us to decouple the infrastructure from the application layer. Next up, let's open up our alarms service and inject the alarm repository provider. Let's also inject the alarm factory. And great, with both dependencies in place, let's update our find all and create methods. The create method now uses the alarm factory to create a new alarm domain model and then passes it to the alarm repository to be saved. Now onto the find all method. The find all method here simply returns the result of the alarm repository's find all method. Excellent. There's just a few more quick things we need to do before we can test everything out in our application. First up, in the source directory, let's create a new folder called common. And inside of this directory, let's create a new file called application-bootstrap-options.interface with the following content. This interface will represent the options that we can use to configure our application. Next, let's generate a new module called core using the NestJS CLI. Let's open up this newly generated module and let's define a new forRoot static method. Essentially here, depending on the driver that we pass in, we're either going to import the type ORM module or import nothing at all. Next, let's open up the app module TS file and declare a new static method there as well, and let's call it register. This register method accepts the application bootstrap options object and passes it to the core module forRoot method. As you can see, it also passes the driver to the alarms infrastructure module use method, which returns the correct infrastructure module based on the selected driver. Let's also not forget to remove the previously imported alarms module that lacks this infrastructure module. Finally, let's update the main TS file to use the register method, and voila, we're all set. For now, let's use the in-memory driver, but we'll switch to the TypeORM driver in just a moment. Okay, so now let's head over to our terminals and start up the application. As we can see, our application is up and running, so let's test everything out using a few simple curl commands. Excellent, both the create and find all methods are working as expected. So let's switch over to the TypeORM driver now to test that out. In order to do that, first we're going to have to create a few things. So let's start by creating a Docker Compose YAML file in the root of our project with the following content. As a note here, make sure that the password matches the one that we used in the forRoot method of the core module. Now back to our terminals, let's run docker-compose up-d to start up that database. Once our database is up and running, let's update the main.ts file to use the TypeORM driver instead of in memory. Let's save our changes again and head over to the terminal and observe those logs. As we can see, the TypeORM module has been successfully initialized, meaning that our application is now using the TypeORM driver in a real database. Let's test it out using those same curl commands. And it works. Fantastic. So just to recap everything, we've created a simple application that allows us to create and fetch alarms. But our simple application is much more than that. We've also decoupled the infrastructure from the application layer using the module's composition pattern. With that simple pattern, we can now simply switch between different infrastructure implementations without having to change the application layer itself. In our case, we simply switch between an in-memory database and a Postgres database via TypeORM. But hopefully you can see this newly gained power you have of now changing between entirely different infrastructures, databases, if you needed to have such a powerful flexibility in your future Nest applications.